Welcome back to 30 Days of Physics with Miss B, and we're moving right along into heat and phase change. Ice cream melting on a hot day goes from a solid to a liquid state. This is called a phase change or change of state. During phase change, the temperature of the ice cream remains constant due to latent heat. Latent heat provides the necessary increase in potential energy of the particles of the substance to cause the bonds within the ice cream to break. This creates spaces between the particles which push against atmospheric pressure. Latent heat is responsible for phase change. It is the heat necessary to change the state of a body without a change of temperature. A heating curve demonstrates how temperature remains constant when a substance changes phase from a liquid to a gas, while a cooling curve demonstrates how temperature remains constant when a substance changes phase from a liquid to a solid. Specific latent heat of fusion of a substance is the heat energy needed to change unit mass of the substance from solid to liquid without a change of temperature. It may be calculated via the expression EH is equal to mLF, where EH is the heat energy in joules, M is the mass in kilograms, LF is equal to specific latent heat of fusion in joules per kilograms. The specific latent heat of vaporization of a substance is the heat energy needed to change unit mass of the substance from liquid to gas without a change of temperature. It may be calculated via the expression EH is equal to mLV, where EH is the heat energy in joules, M is equal to mass in kilograms, LV is equal to specific latent heat of vaporization in joules per kilograms. If power is used to convert a solid into liquid or a liquid into a gas, then the following equations may be used, where we have P times T is equal to mL. Or, since P is equal to current times voltage, we can substitute those variables in for P, and we have IVT is equal to the product of mL, where P will be equal to power, which has units of joules per seconds, T will be equal to time, which has units of seconds, M will be equal to mass, which has units of kilograms, LV is equal to specific latent heat of vaporization, which has units of joules per kilograms, or LF, which is equal to the specific latent heat of fusion, which has units of joules per kilograms. L represents either LV or LF, depending on the phase change. Hence, you would use LF if you're going from a solid to a liquid, or liquid to a solid, and you would use LV if you're going from a liquid to a gas, or vice versa. Let's try some questions. Determine the heat taken in by water to convert 10 kilograms of it at 100 degrees Celsius to steam at 100 degrees Celsius. Note well there is no temperature change. Please also note the specific latent heat of vaporization of water is equal to 2.3 times 10 to the 6 joules per kilograms. Pause the video to try the question. Alright, so the first thing you need to do is to draw out the situation. So you would draw water being converted into a gas, and you would note that there is no temperature change. The temperature is constant because bonds are being broken. That's the easiest thing to remember. Then we have to list all of the variables given in the question. So we already got mass of the water is 10 kilograms, and then we know we're going from liquid to gas, so we'll be using latent heat of vaporization. The latent heat of vaporization of water is 2.3 times 10 to the 6 joules per kilograms. Stick that in the equation, EH equal to mLV, substitute everything, and you will get 2.3 times 10 to the 7 joules. Woo! That's a big number. Hope you got it. Alright, here's another question. How much heat is released when 1 kilogram of icy water at 0 degrees Celsius is frozen solid at 0 degrees Celsius? So there's no temperature change once again, since we're dealing with latent heat. And so we have the specific latent heat of fusion of ice is 3.4 times 10 to the 5 joules per kilograms. Okay, so note well that the number has changed because we're dealing with liquid to a solid, which deals with fusion. Okay, so pause the video to try the question. Okay, so first of all, you're going to draw this out. Draw the scenario out. We always want to place the warmer situation on the right and the cooler situation on the left. That is why our arrow is going backwards, because we're going from warmer situation to cooler situation. Okay, now you list all the variables that were given in the question. You have mass is equal to 1 kilogram and LF is equal to 3.4 times 10 to the 5 joules per kilograms. Then using the equation EH is equal to MLF, you substitute and you get 3.4 times 10 to the 5 joules. Aw, that's such a lovely number. I hope you got that answer. Alright, let's try another question. Determine the power of a heater which takes 10 minutes to convert 5 kilograms of water at 100 degrees Celsius to steam at 100 degrees Celsius. Note that the latent heat of vaporization of water is 2.3 times 10 to the 6 joules per kilograms. You may pause the video to try the question. Now we draw this situation out so we can get a clear idea of where we are going and what we're supposed to do. Then we list all our variables. Don't forget to list. We have mass is equal to 5 kilograms. Latent heat of vaporization is equal to 2.3 times 10 to the 6 joules per kilograms. We have time in minutes, 10 minutes. We convert that to seconds right away because we're looking at SI units. And then we look for the equation that melts our heart and matches our question. So we're looking for power, we're given time, we have mass, and we have LV. So because of that, we're going to use PT is equal to MLV. Transposing for P, we get P is equal to MLV over T. Then we just substitute, put in all the numbers that we already have. Make sure our units match, so when we are trying to get rid of them, we can see what we're doing. And then we're left with joules per second, which is power. The unit for power is actually watts, which is actually equivalent to joules per second. And we get 19,167 watts, or joules per second. Alright guys, I'd like to thank you for watching another episode of 30 Days of Physics with Miss B. See you tomorrow for the 18th episode. Bye!